In this presentation, we have talked about a new topic, length contraction. Consider a frame S which is at rest and having an observer O. The S dash frame is moving with the constant velocity V along the positive x direction, and O dash is an observer in the S dash frame. There is no relative motion along the y and z directions. It means the S dash frame is not moving in the upward and downward directions. At t equal to 0, both the frames coincide. That is, at t equal to 0, O equal to O dash. After time t, the frame S dash is at a distance Vt from the S frame. You know that velocity equal to distance by time, distance equal to velocity into time. Consider a rod AB positioned in the S dash frame. The observer O dash predicted the n coordinates of the rod by x1 dash and x2 dash respectively. Whereas for the observer O, the n coordinates are x1 and x2. Therefore, the rod's length is x2 minus x1, that is equal to L for the observer O, whereas it is x2 dash minus x1 dash equal to L naught for the observer O dash. Now we will know the relative length, that is the length measured by the observer O is entirely different from the length measured by the observer O dash. You know the Lorentz transformation equation. The Lorentz transformation equation is x dash equal to x minus Vt divided by root of 1 minus V square by C square. Keep this as equation 1. Using this equation, we have to develop the equations for x1 dash and x2 dash. x1 dash equal to x1 minus Vt divided by root of 1 minus V square by C square. This is equation 2. Then x2 dash equal to x2 minus Vt divided by root of 1 minus V square by C square. This is equation 3. Now x2 dash minus x1 dash. x2 dash minus x1 dash equal to x2 minus Vt minus x1 plus Vt whole divided by root of 1 minus V square by C square. This is x2 dash, this is x1 dash. x2 minus Vt minus x1 plus Vt whole divided by root of 1 minus V square by C square. This is equal to x2 minus x1 divided by root of 1 minus V square by C square. The left hand side is x2 dash minus x1 dash. Keep this as equation number 4. Then we know that x2 dash minus x1 dash equal to L naught and x2 minus x1 is equal to L. Therefore, L naught equal to L divided by root of 1 minus V square by C square. Now we have to cross multiply. L equal to L naught into this much. L equal to L naught into root of 1 minus V square by C square. Now we have to give the interpretation for this equation. L naught is the length of the rod measured by the observer O dash, whereas L is the length of the rod measured by the observer O, that is the rest observer. Here the factor 1 minus V square by C square present inside the root contracts the length of the rod measured by the observer as at rest as the length measured by an observer in motion. The factor one minus V square by C square inside the root contracts the length of the rod measured by the rest observer as the length measured by an observer in motion, that is L less than L naught. So for the rest observer, the length of the rod is contracted by the factor root of 1 minus V square by C square as the length measured by the observer in motion. So moving observer measures longer length, whereas the observer at rest measures shorter length. Therefore this is called as length contraction. Now we may coin a new term, proper length. A new term, proper length. The length of the rod measured by an observer at rest concerning the rod is called proper length. This statement is very important, and underline the word concerning the rod. See that the length of the rod measured by an observer at rest concerning the rod is called the proper length. Therefore, L naught is the proper length. Because with respect to the rod, who is at rest? O dash is at rest with respect to the rod. If you think about the observer O, with respect to the rod, he is in relative motion. Whereas the O dash observer is at rest with respect to the rod. So the length measured by the observer O dash is called proper length. Once again read out this statement, which is very important for your theoretical understanding. The length of the rod measured by an observer at rest concerning the rod, that is very important, is called proper length. The proper length is here L naught, not L. That's all about the term.